The history of computers began with primitive designs in the early 19th century and went on to change the world during the 20th century. The history of computer goes back over 200 years. At first, theorized by mathematicians and entrepreneurs. During the 19th century, mechanical calculating machines were designed and built to solve the increasingly complex number crunching challenges. The advancement of technology enabled ever more complex computers by the early 20th century, and computers became larger and more powerful. Today, computers are almost unrecognizable from designs of the 19th century, such as Charles Babbage's analytical engine, or even from the huge computers of the 20th century that occupied whole rooms, such as the electronic numerical integrator and calculator. The brief history of computers, from their primitive numbers crunching origins to the powerful modern-day machines that surf the internet, run games, and stream media, is now telling about here. In 1801, Joseph-Marie Jacquard, a French merchant and inventor, invents a loom that uses punched wooden cards of automatic wave fabric designs. Early computers would use the same punch cards. In 1921, English mathematician Charles Babbage conceives of a steam-driven calculating machine that would be able to compute tables of numbers. Funded by the British government, the project called the Difference Engine fails due to the lack of technology at that time. In 1970, the newly formed Intel unveils the Intel 1103, the first dynamic access memory chip. In 1971, a team of IBM engineers led by Alan Shugart invents the floppy disk, enabling data to be shared among different computers. In 1973, Robert Metcalfe, a member of the research staff of Xerox, developed Ethernet and Internet for connecting multiple computers and other hardwares. In 1976, Steve Jobs and Steve Wozniak co-found Apple Computer on April Fool's Day. They unveil Apple I, the first computer with a single circuit board and read-only memory, according to MIT. In 1977, the first West Coast Computer Fairy was held in San Francisco. Jobs and Wozniak present the Apple II computer at the fairy, which included color graphics and features an audio cassette drive for storage. In 1978, the first computerized spreadsheet program was introduced. In 1984, the Apple Macintosh was introduced and announced to the world during the Super Bowl advertisement. The Macintosh was launched with a retail price of $2,500 according to NMHA. In 1985, as a response to the Apple Lisa's GUI, Microsoft released Windows in November 1985. In 1993, the Pentium microprocessor advances the use of graphics and music on PCs. In 1996, Sergey Brin and Larry Page developed the page of Google search engine at Stanford University. In 1997, Microsoft invested $150 million in Apple, which at that time was struggling financially. In 1999, Wi-Fi, the abbreviated term of wireless fidelity, was developed, initially covering a distance of up to 300 feet, which was 91 meters. Then started the 21st century. In 2001, Mac OS X, later renamed as OS X and then simply Mac OS, was released by Apple as the successor to its standard Mac operating system. OS X goes through 16 different versions, each with 10 as its title. In 2004, the Mozilla Corporation launched Mozilla Firefox, the web browser was the first major challenges to Internet Explorer, owned by Microsoft. In 2005, Google buys Android, a Linux-based phone operating system. In 2006, the MacBook Pro from Apple was introduced. The Pro is the company's first Intel-based dual-core mobile computer. In 2009, Microsoft launched Windows 7 on July 22. The new operating system features the ability to pin applications to the taskbar, scatter windows away by shaking another window, easy to access jump list, easier previews of tiles and other more things. In 2010, the iPad, Apple's flagship handheld tablet, was unveiled. In 2011, Google released the Chromebook, which runs on the Google Chrome operating system. In 2015, Apple released the Apple Watch. Microsoft released Windows 10. In 2016, the first reprogrammable quantum computer was created. Until now, there hasn't been any quantum computing platform that had the capability to program new algorithms into the system. In 2017, the Defense Advanced Research Project Agency is developing a new molecular informatics program that uses molecules as computers. Chemistry offered a rich set of properties that we may be able to harness for rapid, skeletal information storage and processing. Computers have been used to coordinate information between multiple locations since the 1950s. The US military SAGE system was the first large-scale system which led to a number of special-purpose commercial systems such as Sabri in the 1970s. Computer engineers at research institutions throughout the United States began to link their computers together with one another by telecommunication technology. The efforts were funded by ARPA, and the computer network that resulted was called the ARPANET. The technologies that were made by ARPA possible spread and evolved. In time, the network spread beyond academic and multiple institutions and became more known as Internet. The emergence of networking involved a redefinition of the nature and boundaries to the computer. Computer operating system and applications were modified to include the ability to define and access the resources of other computers of the network, such as peripheral devices, stored information, and the like. They were used for the extensions of the resources for an individual computer. Initially, these facilities were only available for the people working in high-tech environments. But in the 1990s, the spread of applications like email and World Wide Web combined with the development of cheap, fast networking technologies like Ethernet and ADSL saw computer networking became more usable for all the people. Nowadays, the computers are used for multitasking and multiprocessing. In multitasking, we can define it as while a computer may be viewed as running one gigantic program stored in its main memory. Before the era of inexpensive computers, the principal use of multitasking was to allow many people to share the same computer. Seemingly, multitasking would cause a computer that is switching between several programs to run more slowly in direct proportion to the number of programs it is running. But most programs spend much of their time waiting for slow input-output devices to computers for completing their tasks. If a program is waiting for the user to click on the mouse or press a key on the keyboard, then it will not take a time slice until the event it is waiting for has occurred. This frees up time for the other programs to execute, so that many programs may run simultaneously without unacceptable speed loss. Multiprocessing is used in the computers that are designed to distribute their world access several CPUs in a multiprocessing configuration. A technique once employed is only one large and powerful machine such as supercomputers, mainframe computers, and servers. Multiprocessor and multi-core laptops and computers are now widely available. Supercomputers in particular often have highly unique architecture that differ significantly from the basic stored programs, architectures, and from general-purpose computers. They often feature thousands of CPUs, customized, high-speed interconnects. Input and output is the means by which computers exchange information with the outside world. Devices that provide input or output to the computer are called peripherals. On a typical computer, peripherals include input devices like the keyboard and mouse, while the output devices such as the display and printer. Hard disk drives, floppy drives, and optical disk drives are both input and output devices. Computer networking is another form of input-output. A graphic processing unit might contain 50 or more tiny computers that perform the calculations necessary to display 3D graphics. There is active research to make non-classical computers out of many promising new types of technology, such as optimal computers, DNA computers, neutral computers, and quantum computers. However, different designs of computers can give very different performances for particular problems.